Exam style question on graph transformations. So the question says the graph of y is equal to fx is shown on each of the grids. So part A says on this grid sketch the graph of y is equal to f and then in brackets x minus 3. So this is the transformation here, f and then in brackets x minus 3. So this is our original function, y is equal to fx, and this is the function x. So this is our function of x, and what we need to do is we need to transform it by y is equal to f and then in brackets x minus 3. Okay, so the key to the graph transformation questions is those laws. There are 4 laws, and they affect the, well, two of those laws I'll just show you now. So these are the laws. Okay, so this is actually taken from my GCSE Maths in 4 Weeks program. This is from the main revision guide. And this guide here, it just summarizes this whole guide is about summarizing all of the key properties or keynotes of all the different topics in your exam. So this is my section on graph transformations. As you can see, it's very small. I mean, because this is the essence. What you need to know is you just need to know these 4 rules. So okay, if we have something like this where the transformation is inside of the brackets, so as you can see here, this minus 3 is inside the brackets, then it only affects the x values. So if you have a look at these 2 rules here, just the second rule, and it's actually the second rule and the 4th rule, because these 2 rules in particular, you notice the change happens inside the brackets. Well, what this means is it only affects the x values. The y values actually remain the same. So as you can see here, the y values stay the same in both cases. So, I mean, that's the best way to remember it. And the way I like to remember the transformations in x is it kind of does the opposite, because if you have a look at this rule here, if we've got a plus a here, what it does is it actually shifts the whole graph a units to the left. So let's go back to our question. It says y is equal to f and then brackets x minus 3. So what that means is this graph here is actually going to move to the right, because remember, when it's a positive, it moves towards the left. So remember, it does the opposite when it only affects the x coordinates. But as we've got a minus here, it's actually going to go towards the right. It's actually going to shift. Let me just write this down. It's actually going to shift 3 units to the right. Okay, so what you do here is you take our known points. So here, if you look at this, this is an actual point of the graph, this point here, which is minus 3 to the left and 3 up. This is also a known point. And so what you do is you go by these fixed points, because there's another one down there, which is 1 across and 1 down, so 1 and minus 1. Also, we've got the point at the origin, and we also have another point here. So what you want to do is you want to transform these points first, and then once you transform them, then use that to build the rest of the graph. So let's just transform all of these points. So this point here moves 3 places to the right, 1, 2, 3, so that ends up there. So I'll just put a little cross there. This also moves 3 places to the right, so 1, 2, and 3, that ends up there. The point at the origin now becomes, if it's 0, 0, it actually becomes 3, 0. This point here is actually again 3 places to the right, which ends up here. And lastly, we've got this point at the bottom, which is actually the minimum point of the quadratic function, and that ends up there. So what you do is you start with those points first, and then you use it to build the rest of the graph. So remember, this is a curve, so you draw it by freehand. And remember, it's only a sketch, so it's not going to be highly accurate. But I think the way the mark scheme works is they go by these fixed points here. So you have to actually plot these points correctly. So these points, these known points, so -3, -1 and 3, 3 across and 3 up. These points here, the ones that I've put a dot on, you need to put those in the correct places because those are those points. Those are very easy to transform. Okay, so that is the answer to the first part. So just remember that if it's inside the brackets, it's only affecting the x coordinates. As you can see here, the y coordinates don't actually change. There's no shift up or down, but the only shift happens left or right. And what you do is you do the opposite. So if you've got a -3 here, you actually go towards the positive side, or you move to the right by 3 places. Okay, so let's now have a look at part B. This is part B. And okay, so as you saw in part A, we had a transformation which only affects the x value. So it's unlikely for that to happen again. We're not going to get another question which only affects the x values, or there's only a shift in the x direction. So if you have a look at this part here, it actually says on this grid, sketch the graph of y is equal to 2 fx. Okay, so it's most likely going to affect the y coordinates only. And if you notice here, the actual change, the value is outside the fx now. So if you go back to our rules, this is our 4 rules, the changes outside of fx, they only affect the y values only. So we have y is equal to 2 fx. So this is this rule here, rule number 3. Because it's identical with a is equal to 2 in this case. A is 2, that value in front of the fx. And what it does is, I like to think of it as it does what it says on the tin. So if we've got 2 in front of the fx, what we're doing is we're multiplying all the y values by 2, but the x values stay the same. So as I've written here, the x values stay the same, whereas the y values are multiplied by a. So what it is, it's a stretch in the y direction by a scale factor of a. So it's quite straightforward then. So if this is our original graph, and the original graph is always fx is the same as before. Okay, so we need to transform this point, this graph. But again, what you want to do is you want to go about it by these known points. So let's transform these points first, and then we can build a graph from there. So okay, so we've got these points. These are our original points. So I'm just making. Let's just highlight all of these. That's another one there. And that's that one, right. So what happens here is the x values stay the same, but the y values are multiplied by 3. So if we have, this point here is -1 across and 3 up, the y value is 3 here, but now we multiply 3 by 2 and it becomes 6. So our new point is actually -1, 6. That ends up there. Okay, the point at the origin stays where it is because the y value here is actually 2, isn't it? Because here there's no movement at all. It's just 0, 0. So this stays where it is. Okay, this point here we have 1 across and 1 down. It's -1, the y coordinate here. So we multiply that by 2, and that gives us -2. So what's happening is we're stretching it up and down. It's being stretched in the y direction, so it's being stretched in this direction by a scale factor of 2, so multiplying it by 2. Okay, so if we take a look at this point here, okay, on the x-axis, remember the y coordinates are always 0, so this stays where it is. So this is going to stay there, that's going to stay there as well. And this point here, I think this will transform as well because the y coordinate is 3 here, so this goes up here. So that ends up there. So what's actually happening is, as I said, it's a stretch in the y direction. So let's just join all of our new points up. So remember, this is a point, our new point. This is also a point on our new graph. Remember that 0, 0 doesn't move. That 1 minus 1 becomes 1 minus 2. So that shifts down by 1. And this stays where it is. Remember, any points on the x-axis are effectively going to stay in the same place because the y values are 0, and anything multiplied by 0 is just 0. And also that point there is what has been stretched as well by a scale factor of 2. So that is our transform graph. So as I was saying before, if the change is outside the fx, so if you have a look here, rule number 3, the a is outside the fx, so it only affects the y values. And even if you look at the first rule, again the plus a is outside the fx, so it's only going to affect the y axis, but it does what it says in the tin. Okay, so this wasn't our example in the one I just showed you. We didn't have to use this rule, but you should keep that in mind. So anything outside the fx only affects the y values, and it does what it says in the tin. That's the best way I like to think of it. And anything inside the fx, so here the plus a is inside of it, and in the last rule, again a is inside of it. It affects the x values, but it does the opposite. So that is the answer to our question there.